spreadsheet number 7. This spreadsheet has 11 physicochemical properties of red wines. So we have fixed acidity, volatile acidity, citric acid, residual sugars, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, and alcohol. And in here we have the quality. We have red wine quality. 20 people degusted the red wine and provided grades. The grades were from 1 to 10. Red wine that gets grade 1 is very bad. A red wine that gets quality 10 is very good. So we can analyze these data sets. Well, first we must load this data set in Commander. We go to Data, import data from Microsoft Excel file. Let this row unchecked science samples in the spreadsheet don't have names. Go to OK. Select spreadsheet number 7. And you can visualize your data in here. Normally, every commander recognizes variables that have letters and names as group variable. But since the wine quality was provided with numbers, we must say to the commander that is a group variable. You can save your alterations, and now commander knows that wine quality is a group variable. Well, you might check each one of the physicochemical variables according to red wine's quality. For example, I can go to Commander, and I will check ethanol content. It is common knowledge that wines with high ethanol content is good. It is something that people that likes wine thinks. Wine is with high ethanol content, very good. So I might do a graphics. I'm going to pie chart, and I will do a pie chart for red wine quality. I do red wine quality. I can see that most of my samples were from quality 5 and from quality 6. I have a few samples with low quality, 3, 4, 8, and 7. I have few samples of low quality and few samples of top quality. So I might do also a bar graph. Most of people like bar chart. There is some people that prefer a bar chart than a pie chart. In here you have a bar chart. You can see that the quality 5 and the quality 6 are the qualities with more samples. And you might verify the ethanol content. You might verify it using graphs. For example, you might do a plot of the means for alcohol content. And you might select standard deviations. As you can see, top quality wines have more ethanol than lower quality wines. See that quality 3, 4, and 5 has less alcohol than quality 6, 7, 8. And you have a trend. Increase the ethanol content, increase the quality. But we have large standard deviations, and it shows that it might be hard to differentiate red wines according to their ethanol content. So I might look to this data set again using box plots. I'm going to graphics. I'm going to box plots. I might do a box plots for alcohol. I can see the same trend that I observed in the plot of the means, increased red wine quality, increased ethanol content. But I have large interquartile ranges, and I believe that it might be real hard to differentiate wine's quality according to its ethanol content. I might do hypothesis tests, for example, one way or another, to check if all groups present equivalent ethanol content. First, I go to statistics and I will check for normality. I go summaritz, test of normality, alcohol, I will do a Shapiro-Wilk test. I'm going to OK, and in Studio mainframe, I see that the null hypothesis was rejected, which means that my data was not normally distributed. I can observe data distribution using histograms. I can go to Commander, I'm going to check, I'm going to graphs, and I'm going to histograms. I will do histograms for ash red wine quality. I can see the plot in here. It is better if I check for percents. So I go to histograms. In options, I will put percentage. And I can see that quality 5 has a log distribution. Probably it is because quality 5 has a log distribution. The Shapiro-Wilk test had shown that my data was not normally distributed. My data was not normally distributed, probably because of quality 5. I can see in histograms that quality 5 has a log distribution. So I might go to statistics means, and I will use a non-parametric test. I use the Kruskal-Wallis test. I do this test for alcohol, and it rejects the null hypothesis. What is the null hypothesis? That all groups present equivalent ethanol content. So I can see that ethanol content changes in just groups, but I cannot relate quality. I cannot relate wine quality with its ethanol content. You might also do this evaluation for ash one of the red wine's qualities. You might do the same things that we have done for ash physicochemical variable. For example, you might do a box plot for chlorides. You can see that you have a lot of outlier samples. When you have a lot of outlier samples, you might think that your data set was not normally distributed. For example, I looked at the box plots. I cannot observe any trend in here because I have a lot of outlier samples. Probably quality 5 and 6 has log distribution. I might check this. I go to graphics, histograms, chlorides, options, percentage, OK. As I can see, quality 5 has a log distribution. If I do the Shapiro-Wilk tests, Shapiro-Wilk tests are going to confirm that the data was not normally distributed. So you might use the commander to analyze these data sets. Since it is hard to take any conclusion observing for ash variable individually, in the next video of this playlist, we are going to use principal component analysis to analyze this data set.